With Apple's recent acquisition of Beats by Dre and the fact that they introduced a completely new programming language called Swift, I figured now would be the perfect opportunity to introduce what I would like to call Swift Hoods, which is a place to learn the dirtiest programming tricks that you could ever learn. So to get started, I've got Xcode 6 downloaded right here, and this is the beta version. If you're a developer, you can go ahead and download that from Apple's developer portal. If you're not, too bad, you can suck it. You can't get it until the fall. You will need Xcode 6 for all of these tutorials, so you absolutely have to go and download it. Right now, we're going to learn about classes in Swift and how that's quite a bit different from classes in Objective-C if you're used to that. So you can either start with a new playground, or in my case, I've already got this one started. You'll see that a basic playground starts with just a simple string, and whatever it says here in this string is more or less what's actually going to be printed over here. So you can see how you're kind of getting like live feedback as you're writing the code, which makes this a really ideal sort of place to actually learn how to write the code. In this case, though, we're going to create an implementation of what I would like to call the Kelis class. Those of you who are familiar, Kelis is a particular individual who happens to be in possession of a milkshake that is rather superior to all other milkshakes. Not to mention, she's also offering milkshake instruction at a charge, which is important. It also goes without saying that this particular milkshake, which is in her possession, happens to be the one that can actually bring all of the boys to the yard. So one thing that you notice right away with this class is that it is not a subclass of anything else, which if you were familiar with Objective-C, that might be a little bit different. Basically, classes are their own base class. So in Swift, you can legitimately just say, this is a class. It doesn't inherit from any other classes. It is its own base class. And so what's really cool is automatically we can kind of get started. We know a few things about Kelis. One of the things that we know automatically is that she does have a milkshake. So right now, milkshakes have not exactly been defined. So we should maybe define another class called a milkshake class of some sort. And so we'll do that right here. And so we've got that. And we also happen to know that her milkshake does bring all the boys to the yard. So we should probably have a class for boys. And we should even have a class for the yard, because I would say it's pretty important that there be some type of location. So already, just in talking about classes and trying to implement this Kelis class, we have created many other classes. Now, none of these are subclasses. We don't need them to be subclasses yet. There doesn't need to be any kind of inheritance yet, because, what does a milkshake have to do with a boy, and what does a yard have to do with a boy? None of these relationships are yet defined. A milkshake is not a subset of a boy or anything of that nature, so we can kind of leave this more or less alone. But we do know one thing about Kelis, which is that she does have a milkshake. So we would say that part of her class declaration, one of her properties, is her milkshake, my milkshake. Okay, and we know that her milkshake is of type milkshake. All right, and so this is a property of Kelis. She has a milkshake. But you already noticed that we're getting some kind of a compiler error right here. And it says class Kelis has no initializers. So what we will want to do is actually write our initializer. It's called an init function. And every single kind of any class has its own initializer. And you usually have to specify it just by calling init within the body of the class. And now, right as soon as we created this, we get another error, and it's saying the milkshake is not initialized. Okay, so there's two ways that we can handle this. One is we could initialize the milkshake within the actual declaration of the milkshake. So I could say my milkshake equals milkshake, the milkshake constructor, which is a function that is actually already a part of the milkshake. We haven't exactly defined it, but it is basically the init function. So what we're saying is my milkshake equals milkshake.init. So we're creating a milkshake. But if we decide that we don't want to initialize the milkshake in the actual declaration of the milkshake, then what we could just do is in the init function for Kelis, we could say my milkshake equals milkshake. And boom. So either way that you want to do this is perfectly fine. So that's awesome. So that's one sort of thing about Kelis that we know about. We know that she does have a milkshake. The second thing that we know about Kelis is that her milkshake does bring all the boys to the yard. So we would say that it's rather important that the milkshake itself should probably have a function of some kind that would bring boys to a yard. So some people might want to put that function on Kelis, but really, if you pay attention, it is the milkshake itself that brings the boys to the yard, not Kelis who brings the milkshake. She just happens to be in possession of a milkshake that is capable of bringing the boys to the yard. So what we really want to say is, of the class milkshake, there is a function called bring the boys, which is of type, we got boys, which are of type boy array, to the yard. And you notice that there is no return value on this function. We can even specify that in the actual declaration of the function. We could say there's no return value. So we're bringing the boys to the yard. We're not exactly getting anything back. So this just happens to be something that we know about the milkshake that Kelis is currently in possession of. So let's say that perhaps the boys are capable of going to the yard. That would be an important thing. And they should also probably consume the milkshake too, or at least be able to do that. So this would sort of be a requirement of the boy class, is that it has some kind of a function, go to the yard. So we could say the yard, which is of type yard. Okay, and so maybe what we do for now is when a boy goes to the yard, we'll just have it print a line that says, this boy went to the yard. Okay, pretty simple. And another thing we could say is maybe the boy is also capable of consuming the milkshake. So you could say consume milkshake, and we've got just a milkshake that the boy is consuming. And so maybe we'll just say a milkshake was consumed. And maybe what we want to do is we also want to say give the boy a name. So he has a name, and it's of type string, and it doesn't have any default value, but it's just a string. And we'll actually be able to set that boy's name when we create the boy. And so maybe what we'll say instead of this boy went to the yard is we'll say that name went to the yard, and we'll say name had a milkshake or consumed a milkshake. Okay, so what's this going to do is it's going to say the name of the boy, and it's going to say that he consumed a milkshake. So very important things. Here in our milkshake sort of class, we know that it takes an array of boys. So we've already got some boys that are getting passed to the milkshake. We could say that the milkshake more or less functions as a boy attractor. There's some set of boys that are being attracted from the milkshake to the yard. And so really all we want to implement in this milkshake function is we want to have every single boy in this array go to the yard and consume the milkshake, presumably. So we're going to just make a simple for loop in Swift. And for loops are a little bit different in Swift. They sort of emphasize using the for in type style. So what we want to do is I want to say for boy of type boy in boys. We want to have the boy go to the yard that is specified. We want to have the boy consume the milkshake. And in this case, we're going to use this thing called self. Now, what self refers to is the same thing in Objective-C. It actually refers to the specific instance of the milkshake. So the boy is going to the yard and he is consuming the milkshake that actually brought him to the yard. In this case, it's the milkshake of which Kelis happens to be in possession, but that is the logic that is more or less being spelled out here. So if we kind of zoom out here, we've got our three different classes so far. The yard we haven't really done anything with, we just know that we need one, or four different classes. We've got the boy that's going to the yard, and we've got a milkshake that is actually capable of bringing many boys to the yard. However, you'll notice that over here we don't really have any kind of input or output at all from the console. And that's because none of these classes is really even being used yet. We're just defining what we've done with these different classes. We've got our Kelis class, but we haven't actually done anything with a Kelis class. So what we would need to do is actually instantiate a Kelis. So we would say var Kelis. Notice how it's lowercase. Any specific instance of a actual class you want to have as something that is lowercase as opposed to uppercase, just because it differentiates a smaller an actual instance versus the class type itself. So we want to have it lowercase. We just want to say that small Kelis is equal to Kelis initialized. So it's basically running the Kelis function. It's got a milkshake. You'll notice that this output is a little bit weird if we try and look at it. It just says milkshake because all it's doing is it's reading out what our Kelis has right now, which is just a milkshake.